Today we're going to complete pages 13 through 15 of our notes. Linear equations and two variables. Your favorite linear equation and two variables. Okay, say it with me. Y equals mx plus b. This equation is a line. This equation has a y-intercept of 0, b, where b represents the value for y on the y-axis. The steepness of the line is determined by the slope, or in other words, the rise over run if we're graphing it on a graph. Y equals mx plus b is in slope-intercept form. A vertical line is in the form x equals a, where a is the value of x on the vertical line. The values for y on the vertical line are all real numbers. A horizontal line is in the form y equals a, where a is the value for y along the horizontal line, and the value for x is all real numbers. The next thing we're going to do is sketch a graph of the line. The graph we're going to sketch first is y equals 2x plus 1. I'm going to expand the graph so we can see it a little bit easier. We're going to begin graphing by using our y-intercept. Our y-intercept is this point right here. When we make x 0 and solve for y, we get y equals 1. Therefore, at 0, 1, we have our y-intercept. The next thing we're going to do is use our slope. That's the number 2. Our rise would be 2 and our run is 1. So I'm going to go up 2 and over 1 and make another point. And I'm going to keep doing that until it forms a line. And I can also go in the opposite direction as well. Down 2 and to the left 1. Down 2 and to the left 1. When we connect the points now, we will have a straight line, and therefore now we have a graph of this linear function, y equals 2x plus 1. In this next example, our linear function is written in standard form, x plus y equals 2. So we're going to use a different method to graph this line. Since this equation is in standard form, I can use the x and y intercepts to draw my line. So my first step is to make x 0 and solve for y. As you can see, when we make x 0, y equals 2. Therefore, 0, 2 is our y-intercept. And we can plot that point. We can do the same thing for the x-intercept by making y 0. So we make y 0, and when we do, x equals 2. Therefore, 2, 0 is our x-intercept. I'm going to expand the graph, and we're going to plot these 2 points and draw our line and see what that looks like. Alright, so now we have our x and y intercept, and we can go ahead and plot those points, and from those 2 points we can draw our line. So let's go first to the x-intercept. We have an x-intercept at 2, 0 and a y-intercept at 0, 2, and then we can draw our line through those 2 points, and we have another graph of our other linear equation. Now take a few moments to answer the 2 questions below. What was the difference in the process you used to graph the 2 lines, and what was the same? So think about that for a moment, and in your own words, write down what you think was different in those two processes and what was the same. Next, we're going to look at finding the slope of a line. We can do this in a couple of ways. One of the ways is to write the equation or rewrite the equation in slope-intercept form. If you're given points instead of an equation, you can use the slope formula. The slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, how do you know which point is which and which one is y1, which one is y2, which one is x1, which one is x2? Well, we're going to do the same thing we did yesterday when we set these up. We're going to label our points first, and then we're going to put them into our formula. So let's first label our points in example 1. What is the slope of 0, 4, and 1, negative 1? Let's label those first. So as you can see, I labeled the first point 0, 4, x1 for 0, and y1 for 4. And for the second point 1, negative 1, I labeled it x2, y2. These are the numbers that we're going to put into our slope formula to find our slope for this particular line. I've put my y2, which is negative 1, here, minus my y1, which is 4. So I have negative 1 minus 4 in my numerator. In my denominator, I have x2, which is 1, minus x1, which is 0. 1 minus 0. Let's see what that equals. When we simplify this fraction, we get negative 5 over 1, or simply negative 5. Negative 5 is the slope of our line. In order to find the slope of the line in example 2, we will have to rewrite this equation that's in standard form into slope-intercept form, which is our y equals mx plus b. So we know that m is our slope, so we need to rewrite this equation. Well, how do we do that? Well, that's done in 2 steps. The first step, we subtract the 4x from both sides of the equal sign. So I'm going to subtract 4x from 4x, and I'm going to subtract 4x from the 16. Well, if you remember, you cannot subtract 4x from a number that doesn't have an x. So you have to be able to combine like terms. So these are not like terms. So what I'm going to do is I'm going to keep them separate, and I'm going to write my 4x term first, which is negative because we had to subtract it. So negative 4x, and the 16 is a positive number, so I'm going to say plus 16. So now what we have is 8y is equal to negative 4x plus 16. We have one more step to do in order to put this in slope-intercept form, and that's to divide both sides by 8. We simplify our equation to y equals, and we reduce this negative 4 over 8 to negative 1/2 x plus, and then 16 divided by 8 is 2. So our equation for our line in slope-intercept form is y equals negative 1/2 x plus 2. So our slope is negative 1/2, this number right here. So slope equals negative 1/2. Now we're going to look at writing linear equations in 2 variables, given either a point and a slope or 2 points, and we can write our linear equation as long as we have this information. So we're going to look at some of the different formulas we can use to help us write our equations. First of all, if x1 and y1 is a point on a line of slope m, and xy is any other point on the line, then y minus y1 over x minus x1 equals slope. We can also write equations in the point slope form. This tells us a point on the line and the slope. It looks like y minus y1 equals m times x minus x1. In the first example, let's find an equation of a line in point slope form under the following guidelines. The slope is -3 and it passes through the point 1,5. This is how we would write the point slope form for this line. First, we label our point x1, y1. This will make it easier for us to put it in our formula. Okay, so using this formula right here, this is our point slope formula. I'm just simply entering my y1 and my x1 right here into the formula, so it's pretty simple. Oh, and our slope too, okay? So we put y minus 5, which is our y1, equals -3, our slope, and then in here we're going to put these parentheses, and we're going to put our x minus our x1, which in this case is 1. And that's all there is to it. Real simple. So how can we convert that linear equation into slope-intercept form, which is our favorite form, y equals mx plus b? Let's take a look at it. We're going to look at the point slope form, and then we're going to use some algebra to put this form into slope-intercept form. The first thing we're going to do to this equation in order to put it into slope-intercept form is we're going to distribute this -3. That means that I'm going to multiply everything inside these parentheses by a -3. And the result I'm going to get is going to look like this. Now the last step I'm going to have to do is I'm going to have to add this 5 to both sides of the equation so that I am isolating y. So I'm going to continue by solving for y, add 5 to both sides of the equation, and the result will be my slope-intercept form. So the result is y equals -3x plus 2. Y equals -3x, that's our slope, and then -3 plus 5 is a +2. Now I want you to take a moment and think about the next two questions. What would happen if you were given 2 points instead of point and the slope? How would you write an equation in point slope form? So think about that and give me your explanation in your words of what you think you might be able to do in this situation. A less used form of a line is called the 2-point form. But what is this really? Well, this part right here and this part right here look like the point slope formula, and this point right here looks like the slope formula. So basically what we have here is a combination of the point slope formula with the slope formula included inside for slope. And that's basically it. It's not very often seen, but there you have it. Now let's take a look at another topic you probably remember from geometry. It's parallel and perpendicular lines. So let's look at what parallel and perpendicular lines have in common and how they're different. First of all, parallel lines have the same parallel lines have the same slope. They have different x and y intercepts. If the slope of line 1 is m and the slope of line 2 is m2, the lines are parallel if and only if m1 equals m2. That means that those two slopes need to be exactly the same in order for those lines to be parallel. Perpendicular lines have opposite reciprocal slopes. If the slope of line 1 is m1 and the slope of line 2 is m2, the lines are perpendicular if and only if m1 equals a negative 1 over m2 or m2 equals a negative 1 over m1. Well, what does all that mean? Let's take a look at a couple of examples. The first one we're going to do is we're going to find the slope-intercept form of the equation of the line that passes through the point 2, negative 1 and is parallel to 2x minus 3y equals 5, and the slope that is perpendicular to 2x minus 3y equals 5. So let's take a look at these two and see what kind of equations we can come up with. First of all, to find the line that's parallel to this equation right here, we need to first put this standard form of a line, the standard form of a linear equation, we need to put that into slope-intercept form. So we're going to have to solve for y. So do you remember the two steps? That's right. We subtract the x term, divide from y. Let's do those two steps now. Let's review those steps again. First of all, in order to solve for y, we need to subtract this x term, the minus, we need to subtract 2x from both sides of this equal sign. So we subtract 2x from 2x, and we subtract 2x from 5. Remember, these are not like terms. You cannot combine them. So you're going to write your negative 2x term first, and then your 5. So now we have negative 3y equals negative 2x plus 5. The next step is to divide from y, so we're going to divide everything in our equation by a negative 3. Everything gets divided by negative 3. When we simplify that, we get y equals, since this is a negative divided by a negative, that makes this fraction positive. So our slope is a positive 2/3. Then we have our variable x, and then we have this fraction, which is 5 over a negative 3. That's going to make this fraction negative. So negative 5 over 3. So our final equation is y equals 2x, 2/3 x minus 5/3. Now, that gave us the slope of this line. We're looking for the equation of this other line. We know that parallel lines have the same slope, so we're going to use that slope for our parallel line, but we still need to find this, our new y-intercept. So let's go ahead and put our slope that we found into our point slope formula and come up with a point slope formula for this line. So this is what the point slope looks like, the point slope form. We have y minus a negative 1, that's our y value, equals our slope m, which is 2/3, times, in parentheses, x minus our x value here, which is 2. Now we can simplify this so that we can get this equation into slope-intercept form. So our final result, once we simplify for our equation of a line parallel to 2x minus 3y equals 5 and passes through the point 2, negative 1, is y equals 2/3 x minus 7/3. In example B, we use the same slope-intercept form that we used for this problem because it's the exact same equation. See that? It's exactly the same. So that means I can use this slope-intercept form here. That makes my job a little bit easier because I don't have to redo this step right here. Okay, so I know that perpendicular lines have opposite reciprocal slopes. Well, what does that mean? Well, reciprocal means I need to flip this number over. So I'm going to flip it over to 3/2. And opposite means I'm going to take the opposite sign. So this is a positive 2/3. So to find the opposite reciprocal slope, I flip the number over and I make it negative. Now I'm going to go ahead and put that into my point slope formula. I have y minus a -1 equals -3/2 times x minus 2. That gives me y plus 1 equals -3/2x plus 3. Well, how did I get that plus 3? Well, if you multiply a -3/2 times a -2, you get a positive 3. And if you don't believe me, check your calculator and see what you get. Then the last step is to subtract this one from both sides, and we get y equals -3/2x plus 2. And that is the equation of the line perpendicular to this line. This concludes the notes for lesson 2, and just be sure to take a look over the problems on pages 15 through 17. Those are the ones we're going to be working on in class, and I hope that this videotape was helpful to you in helping you fill out your notes for class. See you tomorrow.